Let's move on to a parallel LCR circuit. Connect your L and R in series and put your a capacitor in parallel to L and R, inductor and a resistor. Okay, so to make the connection, the only change what I make is I remove, I remove the capacitor which was earlier in series and I make that connection to a parallel. Okay, I choose a capacitor in parallel with L and R. Okay, and what I do is these two knobs that will remain open. So in order to close that, I short those 2 points. Okay, now what we have to do is we have to vary the frequency, the input frequency from 100 to 3000. So as you all know, we have to select the frequency knob to 1K. So to vary the frequency, input frequency from 100 to 1000 Hertz. Okay, so let's, for 100 Hertz, note down what is the value of your current, the output current. It is around 16.11. Note down the value of the output current against the input frequency for parallel LCR circuit. Now you vary the input frequency to 300 or set the input frequency to 300. So for a 300 Hertz, we will see that the output current is 15.12 and set the frequency to 600 and note down the value of output current. It is for 600, the value of the output current will be 12.57. 12.57 or 56. Then for 900 frequency or 900 Hertz, the value of the output current we have to note down. Vary the set frequency value to 900 Hertz and note down the output current. The output current for 900 Hertz is 9.53 milliamperes. So you have to keep entering the values in your tabular column as you change the frequency. So now set the value of the input frequency to 1000. Okay, so for 1000 it will be 8.85. Note down the value of the output current against the input frequency. Now change the knob to 10K because behind 1000 we can't use this particular selection. So we have to change the knob to 10K. Then I have to vary the frequency in terms of 1.1, 1.3, 1.5K, nothing but 1100, 1300, 1500 Hertz. Okay, so let's have for 1.1K Hertz, what is the value of the current? For 1.1K, the value of the current is 7.77 milliamperes. So 1.3 the value of the current is 6.85. For 1.7 the value of the current is 8.58. What you have to note down is, as you keep increasing the current at particular frequency, the value will be a minimum. So for our case, the value was minimum at 1100 hertz. Okay, so if you keep increasing the input frequency, let us say 2000, what we could see is the value of the current will start increasing. Now for 2000, we will have the current 10.57. For 3000, the current will be, okay, we have, yeah, almost like 19.99, okay, 19.93 or 91. So like that, in parallel LCR circuit, as the frequency increases up to certain frequency, the current will decrease. At resonance frequency, current will be a minimum, and as the frequency further increases, the current again increases. This is what we have plotted here. Frequency along x-axis, current along y-axis. You can see that as the frequency increases, the current will reach a minimum value at a resonance frequency, and it will start increasing again as the frequency value keep increasing. Okay, so here also note down the bandwidth, note down the resonance frequency, take the ratio of resonance frequency to the bandwidth, that will give me a quality factor. Okay, so this is what a series and parallel LCR circuit, and how we will study the frequency response of a series and parallel LCR circuit. To find the inductance, I use a formula. In series, Ls is equal to 1 over 4 pi square F naught square Cs. That is nothing but capacitance in series. F naught is the resonance frequency. Okay, whereas for a parallel, inductor in parallel, the inductance value is given by 1 over 4 pi square F naught square Cp, where C is the value of a capacitance that we have used in a parallel. Okay, so it will be around 0.176 Henry. It will be around 0.176 Henry. So with this, we could able to determine all three, or we could able to understand all three objectives of our experiment. How does a series LCR circuit or a parallel LCR circuit will respond to the varying frequency of the input voltage, and number two, what is the inductance value of inductor used in series and parallel LCR circuit, and what could be the bandwidth in series and a parallel LCR circuit. Thank you.